So welcome to this lecture on structural elucidation of coniine, an alkaloid. Coniine is one of the simplest alkaloid. So it has specific rotation of it is alpha, it is dextrorotatory and has a specific rotation of plus 15.7 degrees. It is insoluble in water. But fairly soluble in organic solvents. So coniine and its are poisonous chemical compounds. In fact, legend has it that Socrates, in way back 300 BC, was sentenced to death by drinking a coniine containing mixture of poison hemlock. Also, it is not just used as poison, but it is also used as antispasmodic. and and treatment for arthritis. Okay, so we will do the structural elucidation of coniine. First up, so first its molecular formula is found to be, it's a very simple alkaloid, C8H17 and N. So second point, when it's HCl hydrochloride, okay, I'll just put it this way, I'll keep it very simple. When it is distilled with zinc dust, it forms A. So the formula of A is, so you have coniine, which is C8H17N, and when you do zinc distillation in presence of HCl, you get your A. The molecular formula of A is C8H11N, okay, which means 3 hydrogen molecules should have evolved. So A is short of coniine by 6 hydrogen atoms. Point to be noted is A, whatever this A is short of coniine by 6 hydrogen atoms. point 3, A on oxidation with potassium permanganate KMnO4 gives a pyridine carboxylic acid whose formula is C5H4NCOOH. So this is your pyridine carboxylic acid. So there are three isomers of this. So this is your picolinic acid. This is your nicotinic acid. So we'll come to this when we are doing the structural determination of nicotine. We'll meet this person again. So this is your isonicotinic acid. Now by physical properties, by comparing the physical properties of A and these three, okay, A is found to be picolinic acid, which means it is alpha pyridine 2 carboxylic acid. So this pyridine 2 carboxylic acid. Now what this means is that A, so this shows, this oxidation reveals, the information that this oxidation reveals is that, so this suggests no, A is not found to be picolinic acid. The derivative of A, okay, let me put it this way. Sorry guys, sorry. I made a mistake here. So gives, I'll put it as B. Okay. Let me do some. Okay, there is a mistake here. I'm sorry. So what does this suggest? This suggests that your A is a pyridine derivative containing a side chain at 2 only. at two position only. So let us see. What was your Coniine? The molecular formula was C8 H17 N. Your A was C8 H11 N, and your picolinic acid is C5 H4 N COOH. Now what this means is, now if I split the same way as here, this one if I put it as, do a strike, what if I'll write it as C5 H4 N C3, what is remaining? H7, right? So which means your carboxylic group from A should have come from COH group in picolinic acid must have arisen from three carbon chain C3H7. Okay, so now this could be two. A could have two different structures because A could be this one. See, what does KMnO4 do? You should note that KMnO4 just oxidizes the benzylic carbon of this aromatic ring to COOH. That is how you have got picolinic acid here. Now, this C3H7 could be either of these two, and we know that it is, since it is picolinic acid, the side group is substituted at the second position only, and it couldn't be anything else. It is CH, CH3, CH3. So either of these two structures of A. Now A is short of Coniine by, let me use a new page, 0.4. A is short of Coniine by 6 hydrogen atoms. It suggests that Coniine is probably the corresponding piperidine derivative represented by following possible structures. So it could either be, your conine could either be, since there are 6 hydrogens that were missing from conine to that A, your conine has to be either of these two possibilities. Or okay, now how do we know which is either this or this? Okay, so fifth point to note is when conine is heated with hydroiodic acid. Hydroiodic acid Hi at 300 degrees Celsius and high pressure, conine gives N-octane and not isoctane. So this rules out the possibility of conine being 2-isopropyl piperidine. So since so this is formed, okay, but react it with Hi at 300 degrees Celsius and high pressure. This is not formed. Okay, so conine, therefore, the structure of conine therefore is assigned to N-propyl piperidine. So this is assigned the structure of assigned the following structure. This is your no. Now how do we confirm this? Point 6. So formation of coniine by, that is, C8H14 Hoffman's exhaustive methylation further confirms the structure of hmm, okay, there is a beta hydrogen, there is a positive charge, so it has been exhaustively methylated. Then OH from silver hydroxide. So this comes, grabs away this proton, falls back. So what will happen? Minus H2O. So again, what will happen? This nitrogen is exhaustively methylated, OH hydroxide from silver hydroxide will give you. So this is isomerizes to CH2, CH2, CH2. This is Coniine 1,3 or 1,3 octadiene. So this was your structural elucidation of Coniine. So thank you. Bye bye. See you. Next we'll do nicotine.